completing the square, so we just need to review what completing the square is. Just remember, there's two forms of quadratic functions. There's vertex form and standard form. In vertex form, you can solve using the square root property. So you can solve using the square root property if it is in vertex form. Come on. You're fine. If you need one, just let me know and I'll try to find one for you. If it's in standard form, we're going to learn lots of different methods. If A is 1, you are going to complete the square to use the square root property. And this is what we're learning today. I'm going to tell you the other methods that you guys are going to be learning over the next week or so here. And you guys will have a test next Friday over all of them. So that's what we are doing today. Oh my goodness. Hey guys. Stop. So that's where we're at today. Tomorrow in the block we are going to be solving by factoring. So tomorrow in the block, we are going to be solving by factoring. So we will be doing this. So today's the 9th, 410 and 411. I said tomorrow in the block, we will be doing solving by factoring. So tomorrow is Tuesday and your block day.
I apologize.
And then on Friday, Monday, we will solve by using the quadratic formula. I will be singing a song on Friday to help you memorize the quadratic formula, so try not to be absent, because I will be singing.
Can it be a hard metal song?
It will not be, don't worry.
Wait, what kind of song?
It's to Pop Goes the Weasel, and it's to memorize the quadratic formula.
I want one to a metallic song.
No, we ain't into that. You make evil.
I'm not into it. I just want to
what?
Get her on video to remember.
There's a party.
All right. So,
Party
if it's in vertex form, you can use the square root property. Shh. That's the only way we solve. Stop, guys. That's the only way we solve in vertex form. In standard form, there's 3 methods of solving. Today, we will be doing completing the square. Tomorrow in the block, we will solve by factoring. And Friday and next Monday, we will be doing the quadratic formula. So then, next Friday, a week from Friday, you'll have a test. No quizzes before that. So we all understand. So we'll review Tuesday in the block next week, and we'll do some stuff for the EOC as that is coming up. That's what we're going to start reviewing for. Yes?
The calculator does all the work.
Do you not know how to do it on your calculator? Okay, well, it's a part of this process, so you'll learn it throughout this process again today. Okay, guys, does anybody need me to go back? If you need me to go back, please let me know. You okay? Okay, guys. Let's focus. Remember what a perfect square trinomial is. It is one that factors into 2 pieces of the same. We did this about a week ago. How does this factor here? Blaine, how does the first one factor?
I forgot how to do this.
It's literally what we did last week, guys. It's not anything new.
At least he's honest.
So you make x squared by x and x, so it is
X and X.
the x and x in front. What goes in the back if you want to multiply to get 16, but you're adding to get 8? Which one of these?
4.
I'm not playing.
Guys, stop. That's great that you know, but I was talking to Blaine. So, x and 1 and x and 16 is 16x and 1x. Does that add to get 8?
I remember 4 and 4.
4 and 4. Do you guys see how it's the same thing and the same thing? Why did I choose positives, guys? Why didn't I do negatives? Yes.
Because you look at the first sign and it's a positive, then you look at the second sign, it's positive.
So you need either a positive, positive, or negative and negative. So do you guys see? You're not going to know what's going on if you don't stop talking. Just stop. you guys should see that it's the same thing times the same thing, which means it's squared. So let's do the one next to it now. Brian, how does that one factor?
X squared. It'd be X and X.
Good.
Plus 1. Yeah.
But be careful, you're trying to make a -2. So what are you going to do for your sign there? Nope. It has to be 2 of the same. It's a +1 here. You knew what you were doing last week. You can do this, Brian. So it's either positive, positive, or negative, negative.
Be negative, make A.
So what should your ones be? What should your ones be? Positive or negative? What should they be?
There you
Good.
Good job.
So, Mike, stop talking over there. So, x and x is x squared. That's -x and -x to get you -2x. Do you see that middle sign is telling you what you need? So that is x minus 1 squared. So sometimes we won't have a perfect square, and this is where completing the square comes in. What fills in that blank to make it a perfect square trinomial? What fills in that blank, Connor Clover, to make it a perfect square trinomial so that when we go to factor this, it's the same thing times the same thing? What will go in that blank? What goes in this blank? Guys, stop whispering things to people. It's not helping them. Please stop. So you know x times x is x squared. So what would you need to do with your x's to get to 10x? What would they have to multiply by? So think about this. When we distribute this, we're trying to figure out what goes in these blanks, right? So 10 plus 10 is not going to get you... Yeah, you want it to be 5 times x and 5 times x, right? Because 5x and 5x makes it 5x plus 5x is 10x. So what signs do you want here now? Plus. Okay, so what can we figure out for our last terms then? What is our last term then? 5 times 5 is? Plus 25. So that's how you figure it out. So that's why we used the shortcut. We did 10 divided by 2, and then we squared it. What's 5 squared? Do you guys remember this from last week?
Sure.
Because it shouldn't be something you have forgotten already. Does that make a little bit more sense now, Connor? Okay, Connor, your turn. What goes in this blank?
Oh, 4.
Good. So -4 divided by 2 is -2. -2 squared is 4. So those are just a little bit of different ways to kind of think about what goes in the blank. Do you guys see how this is another way you could think about it? Or you could do it this way. I'm trying to give you guys multiple ways to look at that. So those are perfect square trinomials. So let's talk about the steps to completing the square. Remember, we only complete the square in this class when a equals 1. You only complete the square when a equals 1 in this class. Do not try to complete the square in any other situation. I'm looking at you. All right, so here are our steps. You're going to complete the square. You're going to bring the constant to the other side of the equation opposite the ax squared plus bx term. That's your c term. You move the c term. We did this last week. Then, if a is 1, only if a is 1 in this class, you're going to complete the square, making sure that whatever you add to one side gets added to the other side of the equation. We're going to cross this part off. So go ahead and cross that off.
Wow. Screw you, first.
And then you are going to use the square root property. I don't care. I just crossed it off. To solve. And I can change that to a 3 if that makes you feel better.
Yes, please.
Oops, that's not the eraser.
Don't be so picky.
So, after we complete the square, we're just going to do what we did on Friday and use the square root property to solve. The same thing we did on Friday. So you're going to complete the square, and then you're going to use the square root property. When you are ready, flip to the example slides, please. So this says round your answers to the nearest tenth today, so that's 1 decimal place today.
Huh?
Please stop.
Oh, sorry.
All right. Shh. So what are we trying to find? When you are solving, you are trying to find where your quadratic is crossing the x-axis at. What do you know about your y-coordinate when you're on the x-axis? So we are going to say y is 0 because we are trying to solve for when it crosses the x-axis. So the first thing you're going to do is set y equal to 0 if it's not already set that way.
So you just change the y to 0.
Right, because you're figuring out where it's crossing the x-axis, so you haven't moved up or down. So from here, you are going to complete the square. You add the c value. Can we stop, please? We add the c value over, and then we do our blanks. Do those blanks look familiar from last week? Because they should. When we added the c term over, remember we had blanks? I'm not going to go super slow through this because I have a lot of notes to get through, and this is something you guys should already know. So if you are confused, you need to be asking questions in the middle of class and coming to see me. I'm here almost every single day this week before and after school except Wednesday. So come see me.
That's crazy.
Okay, Riley, what goes in my blanks for this one?
Is it 16?
Mm-hmm. So you do half of 8, which is 4, and 4 squared is 16. Remember, whatever you do to one side in an equation, you have to do to the other to keep that teeter-totter balanced. And then this is going to start looking like Friday's lesson. Right from here, it's going to look like Friday's lesson. So there's really nothing new today. It's just combining 2 lessons, okay? So that's kind of what today's lesson is doing here. So 5 plus 16 is 21. Colin, how does that side factor?
Okay, let's see. So what's the question again?
How does the right side factor, the x squared plus 8x plus 16?
Okay, so let's see.
We already completed the square.
Oh, okay, so you do the x first. Okay, and then you have to plug in. Add in. Oh wait, it's.
Say it.
I can't. Okay.
You were about to say a number. What number are you going to say?
2.
Oh, that's not what I thought was coming out of your mouth.
Well, hang on, okay.
I thought I heard you say almost.
Oh, 4?
Yeah.
Oh, okay. 4.
Yeah, because 4 times 4 is,
16.
and 4 plus 4 is,
8.
do you want them to be positive 4s or negative 4s? We want a positive 8, so do we want a positive or negative?
Positive.
We want positive 4s. So you'll notice, you guys will notice that this is 21 equals x plus 4 squared. What did we learn on Friday that we could do when we get to a point like this? You can take the square root.
I don't remember that.
I literally just went over homework problems.
I have a question.
Oh, okay, yeah, now I remember.
No, wait, guys, stop. Guys, just stop talking. The side conversations in this class have got to stop. So this is 4 equals 2 times x minus 1 squared. Do you remember this from Friday? If you think about Friday's lesson. And then we would get 2 equals x minus 1 squared. And then we would have taken the square root of both sides. Do you see how we are at this point in the square root property? It's just that we don't have to move anything because we've already moved it all over to the other side. Do you guys see how similar it is from Friday's lesson now with that example? Does that make more sense, Lexi? Mm-hmm. Okay. So what is the square root of 21, guys?
4.58.
And we're going to go to 1 decimal place today because it says tenth. So we know it's positive 4.6, positive 4.6, and?
Negative.
2 positives or 2 negatives. Typically crosses twice. Connor, what's wrong?
I have a question.
Yes.
On the exam, well, what happened to the 2?
Like the one you did at the top.
Divided by 2.
What?
This was just a random example to show you that it's similar. I just divided both sides by 2. Because you have to isolate this first, so I divided both sides by 2.
Oh.
That was just from Friday's homework.
So you don't do the square root of the thing in the parentheses? You do. But it doesn't check. Oh, okay. Never mind. I get it.
Okay, 1 second, because Connor has a good point. To undo something, we use the inverse, right? Undoing addition is subtraction, right? So when you do 4 plus a negative 4, it makes 0 to undo it, right? So to undo something that's being squared, we take the square root. That just takes the 2 off of it. So this just takes the 2 off of it and leaves you with x plus 4. That's why that's like that. It's an inverse. Okay, so x equals 0.6. And x equals negative 8.6, you said?
Mother.
Okay, so I want you guys to realize how closely this is related to Friday's lesson and the completing the square lessons we've done, okay? So I don't want you to make it more confusing than it has to be. So we are trying to figure out where our graph is crossing the x-axis. When we're on the x-axis, we know our y-coordinate is 0. So we're going to make our y-coordinate here 0. So Emma, what's the first thing we need to do? Subtract 4 from both sides, and then we're going to have our blanks. Josh, what goes in my blank this time? Remember, you're trying to get it so that when it factors, that you can get a 2 in the middle. It wants to be the same thing and the same thing. So what do you have to add together to get the 2 in the middle? 1 and 1, because we know 1 and 1, right? 1x and 1x would get you to 2x. So what is 1 times 1? So that means we're adding. Guys, do you guys see how you could try to factor it before you do anything? If you're getting confused at what to do? The other method we use here is just saying half of 2 is 1. 1 squared is 1. Yeah, it's like that too, but it's just giving you guys different ways of looking at it. So negative 4 plus 1 is? So we have negative 3 equals x plus 1 to the second power. So you'll notice this piece is already isolated, right? We don't have anything added at the end or anything in the front. Do you guys all see that? Yeah. So Mike, what's wrong?
Can you not square root a negative?
Yeah, you guys, if you guys go to put this in your calculator, it'll tell you either domain error or math error, which means it's not mathematically possible, because you can't multiply the same number times the same number to get a negative, because they either have to both be positive or both be negative, and that will always be positive. So that's why this is no real roots or imaginary solutions. Okay, guys, the amount of work I'm seeing on about 5 of your guys' papers is actually pretty sad. This is not easy to do when you go home on your own. So having notes in front of you needs to be there. This needs to improve. You guys are almost done with your freshman year. You're heading into sophomore year. Geometry is a lot of information. You're going to need to take good notes.
Yeah, I know. Isn't it great?
Okay, so these are already set equal to 0 for you. We've kind of talked about why that's the case. What's up, Connor?
Hey, why is that one, like, I was confused on why that one's, like, that answer.
If you tried to take the square root of a negative number.
Oh, yeah, never mind.
It's not because of what it says in the calculator. You need the same number times the same number. But that would mean it's either positive positive or negative negative, which will never get a negative number.
Oh.
All right, Blaine, what's the first step in number 3?
Minus 4 on both sides. Wait, yeah, minus 4 on both sides.
RC, what goes in my blank? Be careful. If you divide it, it's -2. What did you forget to do with the -2? So what is it actually? Huh? -2 times -2 is? +4. There you go. So we get +4. So a lot of you guys are getting that first step of dividing by 2, but you forget to square it. So just be very, very careful not to forget that step if you're doing it that way. If you're somebody that's trying the factoring way, that's also okay. Colin, are you okay back there? Okay. Just wanted to make sure you weren't having a headache over the experience that you're experiencing right now. So -4 plus 0, or 4 is 0. And then we factor this side here. So Kaylee, how does that factor?
X minus 2.
Yeah, you're fine. So we get x minus 2 to the second power. Are we at a point where there's nothing around it? It's isolated so we can take the square root. What's the square root of 0? Is there a positive or -0?
No.
No, so x is just 2. What does this mean for us? Why is there only one solution? What starts on the x-axis?
Vertex.
The vertex is on the x-axis. That is why there's only one solution. Connor,
Hey, you lost me.
where?
First step. Like.
So we always move the c value over
No,
first.
not that step. The step below that step.
Okay,
No, the step below that one. That one, yeah.
Third step.
Why is
the
it negative?
factoring.
Yeah, why is that one negative?
Because if you distribute this, we're trying to add to get a -4x. So we need -2x and -2x to get a -4. If these were positives and positive, it would be a +4x when we added them.
So after you do that, like one step where you finish the square or whatever.
Yeah, complete that square.
You don't do anything else with those numbers? Because I was thinking you have to equal to the numbers that are in black. But you don't.
No.
Okay. Also another question.
Yes.
Why is the answer positive?
Because when you go to solve this, it's 0 equals x plus 2 because the square got taken off, so I have to add 2 to the other side to move it away from the x, so that's why it's positive. All right, other questions? Okay. The first step, Alyssa, is to do what? Not -1. We are adding 1 to both sides, and then we have our blanks. Justin Powers, what goes into that blank? You're fine. Yeah, because divided by 2 is 1. 1 squared is 1 times 1, which is 1. So we get 2 equals, how does that factor, Jordan? Filed. Yes. Connor, do you see why that's this case?
Oh, yeah.
Okay. So are we at a point that it's completely isolated and we can take the square root of both sides?
Yes.
Yes. So we take the square root of both sides. So I get 2 sorry. What is the square root of 2?
1.4.
1.4, we're rounding to 2. So positive and positive and a?
Negative.
We can't forget the negative. That's going to be one of your guys' biggest mistakes. You'll do everything right, but you'll forget the second answer. Is it 0.4 equals x? And negative 2.4 equals x? All right, what questions do you guys have so far? Connor's doing an amazing job of asking questions today. It is okay to be confused. It's not okay to not ask questions. That's where I like the problems lie.
One thing I can do.
Yeah.
Does it matter which, like...
If technically you're supposed to go least to greatest, I would not mark it wrong in this class, but just so you know, it's technically supposed to be least to greatest.
Can you use it in a sentence? Miss Brady, can I do the next one?
In a second here, I have a few people that I want to make sure.
Oh, okay.
Okay. Shh. Guys, this one's a little different. What's wrong?
Hey, there's
Yeah.
30's in the y place.
switched around.
It's already switched around. That means your C value has already been subtracted. So C has been moved.
You have been removed from chalk.
So that means we can just go straight to putting in our blanks. You'll also notice that we're on the other side of the equation this time. Do you guys see that? That's not a big deal. It's okay. We can still complete the square. Don't panic. It is okay. All right. That's an x squared minus 10x, Connor. So, what goes in my blank this time, Brian?
Positive 25.
Yeah, because if you divide by 2, that's negative 5. Negative 5 squared is 25. Connor, go ahead and tell me the factoring of it.
Oh, okay. So x and then the
Blaine,
What?
I can barely see your face. Take your head off. Yes, go ahead.
x's and then the x's and then down negative 15. No,
Where are you getting 15 from?
negative 5.
Where did you get 15 from?
I did the 30.
Oh, I was like, where are we getting 15 from? I got it now.
You don't take the 30?
You have to do the side that has the x squared.
Oh, okay.
It's just because I all of a sudden moved it to the other side, then switch it around and put the negative 30 on the other side then if it confuses you so much. If you are confused by this, you can rewrite it as negative 30 equals x squared minus 10x.
We're good now.
You are all good. Breathe.
Imaginary.
And if you take the square root of both sides, you get that. Can you take the square root of negative 5?
No, because it's negative.
Because you can't.
So guys, what does this look like on a graph? What does this look like for us? It just means that whatever our graph is isn't going to be touching the x-axis.
What a nerd. What a savage. Doesn't even want to touch the x-axis.
All right, we're going to skip and go on to the word problem because Kaylee has already done it, so it makes sense. I know. All right, go to the very last example.
I'm here.
Dang it.
Right there.
I would really pay attention to this. I would stop your messing around so we can get started on this. I'm going to show you 2 different ways of how to do this. We are going to be writing the equation for the parabola with the given vertex that passes through the given point, giving you 2 different ways. So we know that vertex form is the following. That's vertex form, right?
Yeah.
So our vertex is HK, and a point is just like any x comma y on your graph. So if you're looking at this formula, we know every variable in here besides our A value. So we can substitute that in. Y is 4. We don't know A, that's what we'll solve for. H is a positive 1, which means it goes in as a negative. And our K, I missed our X value. What was our X value? 3. And then our K value is 2, and that does not go in opposite. So we can now solve. Do you see how there's only one variable?
Yeah, man.
So 3 minus 1 is
2.
squaring that makes it.
4.
So we have 4A plus 2, right?
Yeah.
So we subtract 2. We get 2 equals 4A, so that means our A value is just 1/2. So if you go to write your vertex form equation, we keep the x and y in there, but our A value becomes 1/2. So we have x minus 1 squared plus 2. So that's one way of doing it. Yes, we are. But thank you for expressing your concern about doing it a different way. So we know that this is the vertex, right? Is that 1, 2?
Yeah.
So that means that if there's a point at 3, 4, we can go 2 away, and there's another point at negative 1, 4. So it's going to create this parabola here. We know that our pattern is typically 1, 4, 9, and then we multiply by whatever our A is. So if they go out 2, they go up how many?
Wait.
Yeah, you're right.
Yeah, 2.
From the vertex, they go out 2. So what did they multiply that 4 by to get to 2?
1/2.
Right? 1/2 of 4 is 2.
Those.
So that's how we know our A value is 2. That means you don't really have to do any algebra because we already know H and K. So we can say 1/2 x minus 1 squared plus 2. So do you guys see that's a different way of looking at it? Okay. So either way, that works. Let me get you guys your